we go. So now we are going to start again. Welcome back. Today is the wireless LAN and the personal area network are the PAN. You can see that these things are truly simple. But if they are simple, then why we are discussing them today? That is the most important point. So you will see that we are discussing them with respect to the wireless networks. And we will try to understand that how many different types of wireless networks are, how many different topologies are, how we can divide these networks, and how we can differentiate these networks, and what are some of the security patterns and issues for the wireless network. Going ahead. So while we are saying that it is the wireless, it means that there is no physical transmission device. It means that there is no physical medium is in interaction, like suppose the cables, UTP, and others, like what we discussed in our previous classes. The main example in our life is the cellular phones or telecommunications, which we call sometimes mobile phone, we call smartphone, gadgets, cellular phone, or telecommunication. These all are means referring to the same thing, the same concept. So all of the telecommunication, conversation and communication is going to be happened wirelessly. And that actually using the electromagnetic fields. And that is known as RF, or the radio frequency waves. So this has happened means without wire. We don't use any wire. And we carry the signals over the part or all of the communication part. Why we are saying it is the part, you remember we discussed already that any of the wireless network always they have at their back end the wired network. So the same mechanism here in the telecommunication pattern as well. So you remember we discussed last time as well that while you are going for the base stations, the towers for the cellular phones, you will notice that the antennas are installed at the top and then they are connected with the ground station. Normally we call that as the BSC, which is known as the base station controller. So those antennas are connected using the black cables. And that base station controller is connected further to the MSC, which is the mobile switching center. We are not going in a more depth for that because that's not part of a course, but just to give you an understanding that whenever we are discussing about the wireless systems, so normally the few of the wireless systems are fully wireless, but the rest of the wireless system are always having at their backbone the wired system as well. Like if suppose we consider the Wi-Fi in the university, in the office, at our home. So you notice that our wireless modems, our Wi-Fi devices, they are also connected with the wired medium. Whatever the ISP service they are providing to us, so we are supposed to connect with them, and then only the last part of it is going to be wireless. That's why we are saying that is the part of or all of that. Now, what it means by the all of that, this is, say for example, we have so many different types of the network in wireless. Say for example, we are going to create a very simple example. We're going to create a network which is using the NFC, are using the infrared, are using the Bluetooth. So we only need the two devices. We don't need any wired backup. So in that particular case, we can say that now this network is completely wireless. So this is actually what the mean why we highlighted that the part are the all the communication. So I hope that you understand the difference between what it means by the part or partially or the 100%. Now there are the few examples for the wireless technology like Wi-Fi, mobile phones, GPS, cordless, home internet, wireless internet, and there are so many. Means we cannot enlist them in the couple of slides even. We just place the link below in case if suppose you are further interested to know about that, so you can, means whenever you have a free time, you can go to that and you can find out that what these things are. Going ahead, wireless LAN, very simple. We know that the network is always having a type like LAN and MAN and WAN and PAN and so many different. They all are actually means referring to the coverage area. We decide their types, that this is LAN, this is PAN, this is MAN, this is WAN. This all are actually, we are deciding based on their operational or coverage area. When we say this is the operational, or when we say this is the coverage area, so it means that it is actually how far they can means extend or provide the signals, and they can cover provide the coverage to connect the nodes. So a wireless LAN, or the WLAN, or the LAN, is a wireless local area network which uses the radio waves. Okay. The last link with this user is the wireless to give a network connection to all the users in a building or a campus. And again, saying that the backbone network usually uses the cables. The same concept, the same things that what we just discussed a few minutes before at the previous slide. So the things are simple, but we are just going towards the more conceptual things. So when the things are simple one, we will try. These things are only for your recap. We will try to go with a little speedy, and when the things are need to our concentration, we will be spending more time on that. Now from this, we are discussing about the common topologies in wireless network. I hope that you know about the topologies, what it means by the topologies. Topologies are simple, nothing to be worried. It means that how the nodes are organized. Now I'm using the word nodes. So node, it means client. Node, it means client, and client, it means the computers. Okay, so these all things are actually the same. So you can see from here with my mouse pointer, we can call this as a node, this as a computer, this as a device, this as a client. This means you can, the client in a mode of the server and client. The node in the network terminology. The computer, like what we are saying, the computer. But we normally say the node. Node, it means that either it will be computer, either it will be means laptop, either it will be the smartphone, or whatever it is. So node will cover to everything. So whenever we use the different terminologies, so you may not get confused. These all things are referring to the same. Now, what about the topology? So you can see that how they are organized, in what fashion they are organized, how they are connected with the network, and how they place to form the network. That is actually known the topology. Now from this figure, if we just follow to my mouse pointer, you can see from here that here you can see one of the channel of the tunnel, and we are mentioning it as an Ethernet. So that is actually the backbone. That's what we were discussing. So this wireless network is not a fully wireless network, but it has a support from the backbone, which is the Ethernet, which is the cable. So you can say that this is your home network, this is your home access point, and these are your nodes or machines which are connected, and this is how it is connected with the ISP, say for example, times internet. And this is the fiber cable is coming to your ISP. So now this is the topology, that how you are arranging the devices at this point. And this is the access point, which we normally call also the AP. And this access point is being used as a repeater. I hope that you understand the concept about the repeater as well. So what the repeater is doing, it is actually doubling the maximum possible distance between them. And it is also trying to not to contribute, but distribute the signals among the different nodes. Do you know that this access point, how many nodes it can control? If you have a one access point, how many nodes it can control? This is the most important point for you. Say for example, the one access point can control number of the users. Then in the offices, suppose in the universities, are in the malls, why we have so many access points? This is something very important. So the right answer for this one is that actually the access point have the number which is limited number of the users to connect. What it is, it's very important. You need to understand it well. It varies actually. What I mean by that it varies actually, in case if suppose, say for example, if we say that the 60 users are connected and they are within the range of the access point, so they are using very internet, like suppose they are using just some kind of the browsing and something, then access point can fulfill almost approximately the 60 users at some time. When the users are trying to use the more bandwidth, increasing the speed, like suppose going beyond the browsing, using the videos and something else, then that number of the 60 will be decreased. Now what happened? How much it will be decreased? In some of the cases, it can go up to the 40, and in some of the cases, it can go up to the 30 as well. And when the number of the users are increasing to connect with the one access point, what happened? Its coverage area is going to be reduced as well due to the load on that. What it means? Say for example, if we say that ideally, just an example for your understanding, that ideally the one access point within the building may have a coverage from 300 or maximum, for example, up to the 300 feet. So it is good, and it will be available only when it is not under the load. When we start putting load on the access point, what happened? The number of users will be increased, the coverage area will be decreased accordingly. The same access point, which was providing the signal strength up to the 300 without the load, but now when we are putting load, so it may be decreasing to the 200 or even less. So this is the reason that we have the multiple access points inside the offices and malls and other infrastructures. So I hope that you understand this is our most important and critical point. So more number of the access points are to keep connected the more number of the users. Now another point may be raised in your mind that if suppose even if we are one of the access point can cover up to 200 feet, okay, in the radius, then it is more than enough. Then again, why we have the more number of the access points? So you know that this is the major issue of the mobility. We cannot bound the people. Say for example, in a university, in any organization, in the railway station, or in any mall. So we cannot fix the access point, some at the predefined distance that we consider that maybe this mall, the people visiting will be normally from 800 to 1000. So we can calculate that this much number and this much access points. No, you will always find the more number of the access point there. The reason is because the movement of the peoples is openly, freely. We don't know that what number of the people will be at what position at what time. So if suppose the people are going to be connected and sitting closer to the one of the point, then you remember that what we discussed, your access point it will not be able to entertain them. So that's why we always have the multiple access points going ahead. Here you can see the further examples that how we can have the different topologies. Now from this, you can see that one of the topology is known, I believe it is more good that you have the mouse pointer. The one of the topology, you can see that this one is as the ad hoc network. So I hope that you understand what it means by that. And this is the temporary situation just for the meetings and the conferences. But this is the ad hoc network mechanism. An ad hoc network mechanism, what had happened, that the nodes are coming, joining together, forming the network, and their topologies are being changed all the time. Sometimes the topology is like this, you can see. Sometimes the topology is like a star, sometimes topology is like a bus, sometimes the topology is like a ring. So I hope that you understand about these things, what it means by ring, star, bus and the other things. Again, they are the different names of the topologies. So it depends. In ad hoc network, what happened? The nodes, they are coming, they are joining independently, and then the nodes, they are leaving independently. So the network is always changing its number of the nodes, and also it is always changing its topology based on the requirement. So this is how we call the ad hoc network. And this ad hoc network, sometimes it is also, we can form the ad hoc network, which is fully wireless. That's what we discussed previously. How wireless networks are going to be connected? What are the components in this? So most of the things are very simple. You know that you can see that this is actually the internet. So you can see that this is the internet cloud. And from the internet cloud, we need here ISP, like the Times. Then it comes to our home, like then they provide us the modem. And then we use the router, or we call the access point. The router or access point is the same, so not to be confused. And then it give us the services to all of our node. So now I hope that you understand what we mean by the node. When we say the node, it means it covers this as cell phone, as computer, as laptop as well. So you can see now he is mentioning as a client, client, and client. So this is correct. Client is correct. If you say this is laptop, this is machine, this is smartphone, again correct. If you say node and node and node, again correct. So not an issue. So this is how the wireless network is landed from in our home or in our offices. Going ahead. Now, what happened? That the access point is always playing a very important role in our wireless networks. What they are doing, they are trying to integrate into the existing networks using through the access point, which is actually providing a role of the bridging. So we can say that we can connect the two of the different networks using the access points, and they help us to connect the with the network, and they also let you stay connected as you roam from one coverage area to another coverage. Now what this point, the second point means? This point is actually, say for example, while you are in the university, say for example, you are just walking around the campus, you are connected with the internet. You are just going to, changing the floor, you are connected with the internet. You are just going to the classroom, you are connected with the internet. You are just going to your lab, you are connected with the network. But did you thought about that? That all the time while you are connecting with the network, you are actually not connected using the same or one particular access point. But you are keep changing the access points while you are moving. So that's what the second point has the meaning. That it is actually playing a role for you like bridging, and also it is making you enable to roam. Roam means to walk around, to change the position. That's what we are saying. We are going outside the country. Our cell phone is on roaming. So it means we are on a mobility. We are walking around. Now we are using the different security mechanisms. At the moment, there are few, and among them, these three are very popular ones: WEP, WPA, WPA2. WEP, WEP is stand for the wireless equivalent privacy or protection. That was the first protocol for the wireless networks, and it was not very much secure. And nowadays, almost it is gone. Most of the people, they are not using this one. Now we are using the WPA, WPA2, and even few more protocols. And we will discuss these all protocols in a couple of minutes in detail. Now, the access point also helping us for the specific interoperability. And also they require the different hardware, X wireless routers as well. Their performance is very good. We notice and we experience everywhere. But when we say that their performance we wish to compare with the wired LANs, this is not possible. Cannot be. Based on so many different reasons that what we are discussing from the day first. Going ahead, these are the few of the devices just only for your brainstorming for the wireless network. Again, we can have a lot of devices for the wireless communication. You remember we talk about the Internet of Things, wireless sensor networks and everything. They all come under the same class or the same category as well. So we have a different and several types of the devices which can be connected using the wireless network. This is the reason that we are saying that their formation of the network, their topologies are different, they are very much open, they are very much challenging, and that is the reason that security is a very highly risk for those type of the networks. Going ahead, this is how we represent the standard sign for the wireless and the LAN. So you can see the two figures. The one is for the wireless and the other one is for the LAN. This is the actually sign for the RJ45. RJ45 is the connector. What we are using with the cable, we call that as RJ45, where we use to connect the pair cable, which is it. Total 8 cables are in a number and they are with a different color code. And we make them 4 pairs out of them and then we connect them. And then we can say the mirror cable and replica cable and so many different types of the cable. I hope you already go through with this and you have the concept about that. That is out of the scope for this lecture. So, but we just means bringing this, some kind of the recap. So as you just know that what is that. Going ahead. Now here is trying to compare the wireless and the wired, both of them. There is no comparison. There is no comparison. But we are just trying to compare just to give you an idea that what are the different things. If we talk about the quality, no comparison with the wired network. But if we talk about the feasibility and the accessibility and the means ease, then again, there's no comparison with the wireless network. So when we talk about the quality, when we talk about the bandwidth, when we talk about the data rates and other things, for sure, we know that the wired networks are. When we talk about the security, for sure, comparative to the wireless network, it is more better. So regulations are the frequencies, just trying to have a quick eye on the slide. Limited availability, coordination is required. Useful frequencies are almost all occupied. Frequencies are also having an issue. In the wireless medium, there are so many other things are also having an issue. Bandwidth is also having an issue. Low transmission rates we having with the wireless networks. So now maybe you can say that we have 5G, people are looking for 6G. So why we are still saying that this is the low bandwidth? Because maybe you are not aware about the wired speed. The wired speed in the Bell laboratories, recently it was tested for the 40 terabyte per second. I hope that you know that what it means by the terabyte. So with the wired, it is the 40 terabyte per second speed gain. Though this is the laboratory test, why I'm saying it's a laboratory test, because whenever we come up with the research, with the new things, the one is the means field are in physical or real life, and the other one that is the normally in the lab test. The lab results are they are under the controlled conditions. So for example, if we say that it is up to the 40 terabytes per second, so it means when we bring it outside physically in the experimental purpose that we deploy it, so maybe that will, or not maybe, but it's sure that we will not be able to get the same 40 terabyte. It will be reduced maybe by 35, by 30, 25, we don't know. when it comes to efficiency. The same thing, the best example you can understand, like suppose for the 5G, the theoretical speed for the 5G is actually 12 to 13 GB per second. But when we have the 5G, so when we have a practically, so we notice that sometimes it goes 1 GB, 4 GB, 3 GB, but I believe even not 4 GB. Not means reach any 4 GB, maybe somewhere around in any particular part of the world. So that's what I mean, that the theoretical and the lab test. So now, even recently, couple of months before, the chip, wireless chip was designed to carry the data for the wireless. That was again, it's inside the lab, it can carry the data 36 GB per second. Again, one thing is that it's in the lab. The second point is that you may ask that why the chip? The chip, because whenever we have the data rate or bandwidth, means the data rate can be only carried if our hardware is supporting to that. For example, if suppose you have the cell phone which does not support the 4G, does not support the 5G, or mostly now we have the cell phones, they does not support the 5G. So in case you support the 5G is in the market, but what do you think that can we will be able to use that? We cannot. Because the chip, because the antenna, because the hardware inside our cell phone is not supported to the 5G. So we cannot. So now I hope you understand that what it means. But again, whatever it is, 36 GB per second, even we compare the lab equivalency. So on the other side, this is the 40 terabyte. And 1024 GBs are making 1 terabyte. So there is no comparison. There is no comparison. But it is more than enough. It is more than sufficient for us. You remember we are discussing and referring to the Wi-Fi 5, we are using Wi-Fi 6E. That is something new, and hopefully by the end of this year or by the next year maximum, we will have it will be available with the new routers, not with the same routers. This is why if you notice that if you are getting the internet connections from the ISP, okay, and suppose someone get the connection few years back and now you're getting the connection, so you will notice that always when they are bringing the routers or the modems, they are different from the previous one. So why it's different? They're not looking for the design only, but they are bringing it different because of these reasons, because the hardware updation. So these all are the differences and the challenges among them. Going ahead, the other drawback is that in the wireless medium, always the bandwidth is the shared medium. Shared medium it means that whatever you are using, that means being used by the others as well. So you are taking a share from the channel. While in the wired, it is a different situation. And the service set identifier, which is known as SSID, is accessible. I hope that you know the SSID. Whenever you just go to your router, so you can find your SSID. Or when you are trying to connect your device with the Wi-Fi, so you can see that this is Taylor network, this is your home network, this is my network. Those names are known as SSID. That SSID is a stand for the service set identifier. The full version for this is service set identifier. This is known as the SSID. There are the properties. If suppose you wish to hide them, so you can hide them from the setting after logging to your router. Okay, so for the security reason, but then it will be hard for you as well to connect. So you can connect with all of the devices, and because once they are connected, then automatically it will be connected. Then it's supposed for the security reason. If you wish to do some changes, you can. So you can play with your own modem at your home, with your own Wi-Fi routers at your home. You can log in, you can see what settings are there, and maybe that will help you for the few of the lab assessments as well. So you can play, you can make the changes. Okay, not to be worried. If you feel that something will be going to be wrong, then there is inside there is the setting that you can make means bring it back to the default setting. But before you start playing, you need to notice that what is your means earlier settings are. So maybe you may not face any issue during this MCO. Maybe the technical people will come late to your home, and maybe you will lose your classes as well. But you can play them wisely with that. Okay, going ahead. Now, I hope that you remember about the OSI. We discussed in our previous classes as well. You remember I advise you that you can remember its name in an easy way, which is the APIST NDP. So you can see from the left side, the APIST NDP are the right side. APIST NDP, A is for application, P is for presentation, S is for session, T is for transport, N is for network, D is NDP, D is for data, and P is for physical. So this is known as the APIST NDP. Now, APIST NDP is actually what it is. These are the 7 layers of OSI reference model. Now, in these 7 layers of OSI reference model, actually, this is a reference model. Okay, so how this application is going to be worked from top to down and from down to bottom. So you know about that. Okay, this is just only means bring it here for your understanding. Now, further, what are the wireless LANs? Like suppose we are using for infrared. In short, we call IR, means which is stand for the infrared. IRDA are the radio links. What are the advantages for this? Overall, with the wireless networks, they are very much flexible. We can form the network, ad hoc networks, and no wiring difficulties. But the disadvantages are the low bandwidth and many other issues that what we just discussed now. So the wireless networks, they have the IEEE standard 802.11, then we say 802.11a, b, c, d, n, g, and so on. We will discuss in a couple of minutes as well. Now for the devices, router. So you know that router means what the router device is, where we are using it, and what it is helping us. So this is actually helping us to connect the different networks at the large distances. And what is the job for this one? The main job for this one is to forward the data packets. So in other words, we can say the router is actually trying to connect the two different types of the networks. Means we can say simply to enable us to connect the different types of networks. This could be the correct as well. What it's doing, the primary job of the router means controlling the data packets, and it means helping us to reaching the data packets from the source to the destination. What data packet is? Data packet, you know that is coming up with its header, with its information, the encryption and other things, whatever we discussed previously, we applied on that. So all of our data streaming, they are coming in small chunks, that is known as the data packets. And that data packets, they contain the information, the source and destination information as well. And it contains the destination information, their IP address, where to go, what network has to go, everything. That is the information in the header as well. So these all things are going to be handled with the help of the router. Now, how the router is working and where the router is helping us. The routers, they are helping us at the layer number 3, which is the network layer. Going back, if you remember, we just discussed why we bring this OSI reference model here. Just to give you an idea that how and where the router is working. On layer number 2, which is the data link, the switches are working at the data link. And on the physical link, we are using the house. So this figure can give you the more clear difference as well among the router, switches, and hubs. Going ahead, then we are using the bridges. Now we are trying to discuss the different components of the wireless networks, which makes us enable to form the wireless. So the bridge, what it is doing, the bridge is actually connecting the two networks. Or if in case if suppose the networks are big, so we are trying to divide the two networks into two different types. So that is also we are able to do that with the help of the bridge. You know that your bridges, they have their own processor and memories, and also they have their two NIC cards. What is the NIC card? The NIC card is actually stand for network interface card, the port where we connect the RJ45 cable one. Okay, so this will facilitate to host the communication, and this is also applied at the physical layer as well, and the data link layer as well. So this is known as the bridge. Now, what is the importance of the bridge? Actually, when we have a very big networks in wireless, so we are trying to divide them into two, or in case if suppose we have the two different networks, so we are using the bridges to connect with them. Very simple from its name, like it's a bridge. So bridge, it means there's something which is connecting the two things with each other. Further, here are the further functions of the bridge, that what it is doing. Just for your understanding, a bridge is as the physical layer devices, and it generates the signals it receives. As a data link layer, if you remember, we mentioned it here that this is working, it operates at actually the physical and the data link. So now you can see from here that it is the physical and data link layer. What it's doing, it sends the data frames only to the concerned destination. We use the bridges also for separating the large networks, and also to filtering our data packets and frames. So it is because applying the filtering, so that's why it is automatically controlling or minimizing the unwanted traffic. So any traffic which is not supposed to come to the particular network, it will stop that. So what and how this mechanism helps this mechanism helps us to minimize the congestion. And congestion is actually a big problem in the wireless networks. So the next is the error links can be identified in case if suppose the errors are there, so they can be identified as well. So there are the security features or access control can be added. In fact, we can applying some level of security by using its filters and other mechanisms. So these are the functions of the bridge. Then we are going towards the next step, which is known as the gateway. So what the gateway is doing, to connect the two network that uses the different protocols. This is the most important. Now, while the two networks, they are using the different protocols, then we need the gateways. And the gateway normally work on all of the 7 layers, not like the bridge network and physical and data link layer. But this will, you can see it work on the 7 layer of the OSI reference model. The gateway is the same that you are using at your home as well. So unlike a router, a gateway can forward the packet across the different networks that may also use the different protocols. So router work on the network layer, switches work on some specific layer, which is the data link layer, and the hubs, they work on the physical layer, and the bridges, they work on the physical, the first 2 layers from bottom. But the main difference for the gateway, it works on all of the layers. So that's the difference, and this is helping us while suppose the network, they are working for the different protocols, so they can keep them connected. So gateway, you can see from this figure, it's showing that the gateway at all OSI layer, starting from physical data application or from application to at all the layers. It helps us to work and connect the different type of protocols of networks. What are the main functions we already discussed? So it has the abilities to translate between the different frames format and between the different protocols. So this is more powerful. And it's a very powerful computer system compared to a bridge. Why we are saying it's very powerful? Though bridge is providing us filtering, though bridge is providing us the connectivity of the two networks, though the bridge is providing the segmentation of the two networks, though the bridge is actually helping us to control the congestion, but the bridge is only working for the two layers. Okay, so this is more powerful. It's working on all of the layers, and it is connecting the two different type of the networks which are using the different protocol. That's why we can say, sorry, this is the difference. Now these are the few of the in-depth technical informations which you are trying to get from this lecture. The previously what we discussed, so they were the recap on the simple concepts, but we are coming towards this, so that's why we were required to have that recapping as well. It used a huge and incompatible networks as well. So for this gateway, there's no issue for having the huge networks are incompatible networks. It's fine for that. Now the types of the wireless networks. We discussed what is a gateway. We discussed what is the hub. We discussed what is the switch. We discussed what is the router. We discussed what is the bridges. We discussed what are the devices of the wireless. We discussed how the topologies are going to be formed. We discussed what are the different structures of the network in the wireless. Now we are coming, when we have this all information, now we are coming one step ahead to say that what are the types of the wireless network. So you remember that I said that the IEEE 802.11, this is the international standard for the wireless. So whenever we have 802.11, then maybe we will have something after that, something different. But the 802 is a fixed standard for wireless. You will see in a couple of minutes. Now, what are the types of the wireless network? Actually, on an architectural base, we divide it two main types. One type is known as BSS and another type is known as ESS. This is very important. BSS and ESS, what they are, the BSS is actually basic service set. BSS is stand for basic service set, and ESS is stand for the extended service set. So now we need to understand what is the basic service set and what is the extended service set. So here you can see that these are the specifications of wireless net defined by whom? By IEEE International Standard Body. Okay, that covers the physical and data link. Okay. Now the architecture basis, we divide it into the two, BSS and ESS. What they are and how they are different from each other, I'm going to understand that. BSS is what? BSS is building block of a wireless network. Building block, it means it's the base, it's a necessary component of the wireless network. It can be made of the stationary or mobile service stations, not an issue. Access points, we will focus them as AP later on, so not to be confused with this one. And optional central base station. Without an AP, this is known as the ad hoc network. And ad hoc, you notice, if you just allow me to take you back, it is going back to our previous slides where I showed to you, this is the ad hoc network. So you can see from here that there is no access point. We don't need access point here. Not necessary. Have it or not, it's not necessary. Now, what he is referring now here, in this he is referring the same thing, that without an access point. It's standalone, if it is without an access point, then this is the ad hoc architecture. The standalone network can't send data to the other BSS. So BSS is the one structure format. We may have multiple BSS in the wireless LAN, but how it looks like, just wait for a minute. You will see the figure. The one figure is more than clear than the 1,000 number of the messages, so you will understand. Can form a network without the need of access point. with an access point infrastructure network as well. So it uses access point as well. It can be formed without access point. It can be for distribution. It can be for the mobile service. And what it is, how it is. So this is the figure you can see from this one. So from this figure, you can see that this is the BSS. BSS is stands for the basic service set, and AP is actually for access point. So in these two boxes, you can see the first box, we don't have any access point, but we have a station, a station, a station, a station. Going back, a station, a station, a station, a station. We can say node, node, node. We can say computer, computer, computer. We can say client, client, client. These all things are the same. So please don't worry, don't confuse yourself. But see at the bottom, what is the label for this one? We are saying that this is actually this is actually the ad hoc network BSS without an access point. We're saying that this is something where we don't have the access point. This is the difference for that one. Okay, you see to the next means square box, what it is and how it's different from the other one. That actually contained in the center access point. And what is actually access point? The access point is actually your gateway, your router gateway, what you are using, what we are using in offices and everywhere. That is the means known as the access point. So now this is, we are calling this network, if you just come back, means down at the bottom, you can see that this is saying that the infrastructure and BSS with an access point. So what do you mean by the infrastructure now? Why he didn't see the infrastructure to the previous one? Because when we are coming up with this, it means we have an access point. And you know the access point, remember we discussed in earlier slides. So the access point, it means that it is connected with the wire at the back end. So while it is connected with the wire, it means that the infrastructure is there. While we don't have the access point, it means that is the infrastructure less network. So if it is infrastructure less network, then what it mean? Going back. So you can see from here, it can be without an access point. So we call that ad hoc architecture. And if it is with the access point, then we can call what? We can call infrastructure based BSS and access point. So this is the difference between both of the square figures. I hope now you understand very clearly that what we mean by the basic service set are the BSS. Normally, we call it BSS and ESS mostly, but it is stand for the basic service set. Going ahead, now in this figure, you can see that this is the ESS model. In the ESS model, what we are going to do, actually the ESS model is extended service set. It means when we have multiple BSS, how we can interconnect with them, or how they are connected with each other. That model is known as the ESS. So you can see from this figure that the ESS is extended service set, BSS is the same basic service set, and AP is access point. So you can find from here that there are the 3 different BSS, and then we are connecting all together with the help of the access point. They are connected with the distribution system, and that is going to the server or the gateway. So this would be known as the extended service set or ESS. ESS, it uses 2 stations, mobile and station, because it is extended. So this is ESS is always means a larger compared to the BSS. And the mobile stations are normal stations inside a BSS. Okay, so the rest of the property we can say that they have the same like the BSS, because the BSS is actually the extension. The ESS is actually the extension of the BSS. So what is saying that when BSS are connected, the stations within the reach of one another to communicate without the use of an access point as well. So the rest of the model can be formed the same what we discussed in the BSS. So in simple word, we can say that what is the baseline difference between the BSS and the ESS. So the BSS, you can say that it is the independent, separate, alone network, but the BSS is means the combination of the one, two or more than two BSS, not one, but two or more than two. Now, the station type. What do you mean by the station type? I remember going back what he was calling to the station. See, this is the station. Means node, means computer, means client. So what is the station type? No transition, BSS transition, ASS transition. No transition, it means either stationary, not moving, or moving only inside the BSS. Those stations, those nodes, those computers, those machines, they are stationary, they are not moving, they are fixed. Okay. In case if suppose moving, but they are moving only inside the BSS. Like suppose we are connected with our home network, like in this situation. So our computers, our laptops, our mobile phones and everything, they are connected. Okay. But then what happened? They are connected in how they are connected within that particular BSS. So your home network is actually your own BSS. Okay. Now, what's the BSS transaction? Move from one BSS to another, but the movement is the confined inside one BSS. So when we are moving from one BSS to another BSS, like going back to this one. So what he mean that we are moving from here to here, here to here, here to here, no problem. But these all three, they all are the one set of one ESS. Maybe we have another set of ESS here, another set of ESS here. So he's saying that we are not moving from one ESS to another ESS, but we are moving within the one ESS. Then this is known what? Then is known the BSS. So BSS transition within the ESS transition. ESS transition can move from one ESS to another. So it means that now we are moving from this one ESS to another ESS to another ESS. So it means that we have three movement pattern. One is that within this BSS, we are not going even from this to this. Second thing is that among the BSS, but we are not changing the ESS. Third one is that we are also changing the ESS. So these are the three different transitions. No transition while you are sitting at home now. You're not going anywhere. BSS transition, it means while you are in the university. ESS transition, it means like you are going to, means traveling, you are at home, you are connected with some different network, with some different ESS, you're going to connect with the mobile data while you are on move, you are connecting with a different subset of network, then you are reaching to the university, you are going to connect with some different sort of network. So this is the ESS transition, BSS transition, and then this is the means no transition. I hope you understand these transitions, they are very important. Now, what are the wireless standards? So you remember we said the evolution of 802.11. 802 is something which is fixed. Okay. Then you can see from 802.11b, 11g, 11n, 11ac, could be any. And this is not done. It means the research is going on and the new things are coming. Always and always and always. So what in the new things are coming? New things, they are coming up with the more bandwidth, with the more means efficiency, with the low latency, and the with a good output and these things. So you can see this was 11b. So normally, why I'm saying that 802 is always be there. So normally, whenever we in our security or in our network particular means domain, whenever we refer them, we don't refer like 802.11b like that. We normally say 11b. 11b, it means the 802 first is means understood that it is there because of the wireless. So now we will also say like this, so you may not get confused. So you can see from there, 11b is actually, it was there in 1999. Now see the speed difference. It was having the speed for 11 Mbps. It means in 1999, someone was using this standard and the hardware can support only maximum 1 Mbps. So that person cannot use the 3G, 4G or 5G, or at least 4G and 5G. Then 11G, it goes up to the 54 Mbps. Remember, these speeds are the means lab speed, theoretical speeds, not the practical one. So then 11N, this is up to 600 Mbps. Then the 11AC, this is the breaks the gigabit per second barrier. So in your cell phone, in your laptop, if you have the means hardware standard up to 11N, 11G, or 11B, you will not be able to connect with the Wi-Fi. Nowadays, Wi-Fi means up to the maximum speed. So you notice, maybe not. If you don't now, after today, you just try to notice that point. What that point is means, suppose you have a multiple laptops and your cell phones at your home, and you have provided if you have a latest modem at your home, so you will find that your latest modem, it will showing you the connectivity for your wireless with the two different means aspect with the 2.5 and 5 gigahertz. So you will notice that your few of the laptops, they will be, or few of the devices, they will be only able to connect with the 2.5. They are not able to connect with the 5. Why? What's the reason? This is the reason. That's what we are discussing. That what type of antenna or hardware support is there. So if your device does not have a support to connect with the 5 gigahertz, it cannot be. Now you know that what's a gigahertz. We discuss in our principles of the wireless transmission as well. So you see the things are how the missing blocks are going to be matched with each other. They are very simple. Okay, so going ahead. So now you know that why you are not able to connect with the means 5G, but you are able to connect with the 2.5G in case if suppose you have the old laptop or old device at your home. So in the same way, the 6E we will discuss later on. So 802.11, so means this is a set of the media, okay, access control, which is media access control, that is known as the MAC. Media is M, access is A, C is control. So normally you notice that there are so many times that we have the network terminology, we have something is known as MAC. So I hope now you understand what is the meaning by the MAC, what the means are considering from the MAC. So the MAC is actually the media access control. It is sent from the media access control, also known as the data link layer, which is also known as the data link. Data link layer, it means after the physical, the physical link and then the data link layer, the second one. So the MAC is the second layer, data link layer, and physical layer, that is the first layer, specification for implementing the wireless local area network. So this IEEE 802, it is implemented for first two layer standard. This is the physical and the data link layer, 802.11. They are the world most widely used wireless computer networking standard. Okay, so this is the standards, they are released in 1997 and so on. So just we are going ahead because this is only the standard, no need to discuss further on this. So now you can see from here that these standards and these values are the parameters, date of standard approved, maximum data rates, you can see from the table. So this is the year and this is the speed. So that's what we discussed just in our previous slide. So this is the same thing. So we are just going ahead. Now that was, if we just go back, so you can see that this is the 802.8A or 11A. So if you allow me, just going back, so you can see from here that this is the 802.11B, 11G, 11N, 11A. See, so this is the same thing. Here he is just trying to give us the more detail about it. So we know about 11A, how much it can go and how much 11B can go like this. So now you can see that now this is actually describing us about the 11B. So the 11B is more advanced than the previous one. Okay, and it was only after the 802.11F was rectified and the product became available that Wi-Fi took off in a large way. So after this, the Wi-Fi was being operated in a commercial basis. Previously in even the late of 90s, there was no Wi-Fi. There was no Wi-Fi. And if I just tell you, while I was doing my master's, at that time the internet speed was, we were using the internet we connect the internet with the normal our the landline phones. At that time, no Wi-Fi, no WiMAX, nothing, but you have to connect the internet using the ISP, but through your land phone. Do you know what was the speed of that one? The maximum theoretical speed with that cable was 56 kbps per second. Hey, this I'm saying kbps, not mbps. So what happened if at that time the browser does not contain the figures or pictures, okay, the contents, because they were heavy, so they cannot load. So most of the browsers, they were only having the contents. So then what happened when it is connected with the internet, then you can see the smile on my face or anyone person face who is using the internet at that time. Then the most common email browser at that time was being used Yahoo. And there was no so many such smartphones and these smart applications and social networks were there. No, not at all. No YouTube was there as well. Okay, not common, not popular, not common, because there was no bandwidth. So sometime if I just open the Yahoo page and if suppose I enter the login ID and detail, then it's better that I can go and have a tea or coffee and come back, and then I will be able to see. So even though the people were happy, oh wow, now there's speed, we can send the email. Previously, we were sending the the postal cards and Eid cards and gift cards to our families and friends whenever this. So that means taking a time of weeks to reach them. Now we are happy that in a few minutes we send the email so they can receive. The people were happy. Now if suppose we go back for that speed and we give it to you, now the mentality of our people, because now we are used to with a very high bandwidth speed, the people will start crying. They will be mad. Now, nowadays, the food is the very compulsory requirement for us. But nowadays, the most important point for us is the internet connection. So if you don't have internet connection, so it means that we will be out of our mind. So anyhow, going ahead. So in the same way, you can see for the 801.1b specifications. So these are now the specifications for all of them one by one after each other. So we are just going quickly because these are the only theoretical information. So you can just go through the technical points we already discussed about them. So 802.11g. This is the gigawatt means to at the 2.4 gigahertz, but much less than wants to run at the 5 gigahertz. And this is using the ISM band and so many other things. Okay, so this is 11G, and previously we discussed about 11B and 11B, 11A, and so on, and 11A simple and so on. So like this, and this is the more further specification that how it's working and how it is doing that. It means things. Now we are coming ahead because those were the standards. That's why we just go quickly. Now we are coming ahead about the wireless security protocol. We need to see that what are the security protocols now. That is the most important point now, because we have to take care about this, because these all things we are discussing, trying to understand, and everything. This is just to reach that how we can manage the security of the wireless network. So you can see from here WEP, WPA, and WPA2, and so on. So Wi-Fi security techniques are mainly three: WEP, which is wired equivalent privacy; number two, WPA, which is the wireless protected access; number three, which is the wireless protected access. But this is two, means this is the latest version for that one. WEP, the first one, which is known as the wired equivalent privacy, means it was the first it was introduced, and it was considered that this is the having the same privacy as the privacy level we have in our wired network. But it was not in actual. It was very, very weak. So it was a short form of the wired equivalent privacy, a security protocol for wireless local area networks, WLANs, defined in the 802.11b standard. WEP is designed to provide the same level of the security as that of the wireless LAN, but this was actually not correct. Okay, and this is why we have the further. So WEP aims to provide the security by what by encrypting data over the radio waves. So it means it was providing the encryption while the data is being traveled. Okay, now why we are not able to apply the same security algorithms or standards what we have for the wire network and the wireless? We cannot. We cannot. Why? That we cannot because of the mode of the operation. Because this wireless means data packets, this wireless transmission, it cannot bear the same means amount of the loads, amount of the calculation, amount of the means this is in other words we can say that this is the lightweight and this cannot means carry the same amount of the load what we means put on the wire net. That's why the all of the algorithms, most of the algorithms are means designed for the wireless networks are different, and they are for the wired network they are different as well. Now the point is that the however it has been found that WEP is not as secure as once believed. The point when they came up with this algorithm, they thought that it's good, but actually it was not good and it is not good. I'll give you the one example. This is maybe we will be going a bit out from here. You remember that we have the cellular systems, maybe we referred in some of the lecture, that we talk about we had the cellular system AMS, okay, which is AMS is actually stand for the analog mobile phone system, AMPS. So that was the first generation for the wireless because it comes into the wireless. That was the first generation for the wireless. So in that cellular phone, while the people they were using to talk with each other, what happened? Your call can be cross-talk with others. So most of the time, you are able that the two other person they are talking to each other, and you are able to listen to them. So where is the security? That was the some sort of the privacy and security issues at that time. So after that, they started it how and why we can come up with the protocol while the data is on a travel and a means communication. So on a move, so we can apply that encryption to stop that. So they come up with the WEP and they thought that this is something very good, but it was not. Okay, WEP is used at the two lowest layer of the OSI model. Which are the two lowest layer? The physical and the data link layer. That is the data link and the physical layer. It therefore does not offer end-to-end security. So we cannot say that it is offering us end-to-end security. End-to-end security, it means what? It means that it may work on all of the layers. Like your WhatsApp is claiming that they have end-to-end security. Okay, maybe one of the lab or one of the tutorial you go through with that one. I don't remember in which module that we thought that what is the end-to-end encryption or the security, what the WhatsApp is claiming. So what is the reality about it, blah, 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 whatever it is. So I hope that you understand. Now we may stop today here. We are not able to finish this lecture because now we only left a few minutes in our next lecture as well. And meanwhile, we have to go for the attendance as well. This lecture contains almost 60 slides. So we will again recap in the next. We will start from slide number 37. So anyone out of you can be helping us to remind it from where we can start. So we will finish this and then we will go for the next lecture as well. So you just may have a look because the upcoming concept, a few of them they are a bit important. So that's why it's not better that we just finish them quickly. So these things we will make them done in our next lecture. So thank you very much for today. We will continue from slide number 37. So now in case this will be our slide from where we will continue in our next lecture. Now, if you have any questions, please let me know. Meanwhile, I just go for your attendance to open your attendance. So here we go. Yeah, receiving the, okay, just allow me to stop the recording. Okay, where we are, here we are. So we'll stop recording to go for attendance. If you have questions, please let me know.